Good evening YouTube, I'm TBJ and this is TBJ's Tech Stuff. Tonight I'm going to show you my design for a fully discrete stepper motor controller. So we have 4 separate logic devices here. There's actually 3 chips, there's 2 flip-flops, 4013 flip-flops, but they come as 2 in a single package. So the basis of this is a 10-stage Johnson counter here. That goes to your outputs here. You've also got a 555 timer, which is the logic clock, 2 flip-flops. One of these flip-flops triggers the counter, so when you apply an input here which goes to the clock line, it latches itself high until such time as the counter counts down to number 9, which is the final output, and it resets the flip-flop back low again. So that means that each of these lines goes high in turn. You've also got this flip-flop here which sets a direction, so when you're going one way or the other you only want half of these lines to go high. So what this has the effect of doing, when depending on which one of these outputs is high on the flip-flop, it grounds half of these lines. Very simple. As you can see, I'm just going to hit the step button here and you can see how I'll set the direction the other way. Hit it again and you can see how it triggers 4 of the outputs in sequence. All you do then is wire these outputs to an H-bridge driver, well, dual H-bridge, and that runs your stepper motors. Here is the prototype set up on a breadboard. On the breadboard there's a couple of changes from the design on the computer, in that you've got a voltage regulator here which provides 5 volt for the logic chips. Everything pretty much the same. Like I said, you've only got 1 flip-flop chip because there's 2 in a chip, and the outputs of that are wired to a set of H-bridges here. These are Mark Tilden's 6 transistor H-bridge design, which I adapted for my use. So this is wired to a stepper motor which we salvaged from an old printer, and a Velleman K8055 interface board. What this does, this takes signals from the computer, which is here, and converts them into outputs that go to the board to drive the stepper motor. What we've also got here is a VB program which I wrote, only a few lines of code, and what this will allow me to do is step a certain number of steps using the motor. Let's test it out. Connect the battery here. See, there's the motor. Just move that over there so you can see it a little bit better. So I'm going to try a single step in it first. As you can see, it does work quite smoothly. Now, to prove it's accurate, I'm going to step it 100 steps to the left of its current position. So, in fact, I'm just going to set that so it's in a known position. Alright, so there we are. So we know that that's pretty much pointing straight now. So I'm going to tell it to move 100 steps to the left. Just let it do that. Make it move another 100 steps to the left, just to be on the safe side. Okay, so as you can see, it's gone quite a distance that way. Now I'm going to make it move 200 steps back to the right again, and what should happen is it should end up in exactly the same position where we started off. Right, as you can see, it has. So there you go, one stepper motor controller made out of cheap components you can get anywhere. Hope you've enjoyed watching, and please see the link at the end of the video for some schematics. Thanks.